All right, so one last practice set of problems before your test tomorrow. Saw a couple people grab this. I'm hoping that this will help some folks. I'm going to walk through step by step what you should be doing as you look at any problem. And so I'm going to do one problem at a time, and that way you can look at it, set it up for yourself, work it, and then if you watch the video, you'll see me go through it to see if you had it right or wrong. So problem number one in the last practice says, how long is a football field, which is 300 feet? The desired answer is in kilometers. That's what we have, what we want. So always set up your problem the same way. The given information over 1. So in this case, 300 feet over 1 just puts it in the fractional format. So we need some conversion factors next that will get rid of feet and leave us with kilometers. And looking at the possibilities for conversion factors, there are a few that might be useful. So if we look at something that has feet, well, 12 inches to a foot, but that goes small, not big. We're going to go up from feet to kilometers. So feet to a mile, that's going in the right direction. And then from a mile, we want kilometers, so mile, and there's a mile and kilometers. So we're kind of checking ahead of time what sort of conversion factors we might want. So if I assume we'll use this one, 5280 feet equals 1 mile. I've got a feet at the top, which means I need the feet at the bottom to get rid of it. 5280 feet per 1 mile. One of the things I noticed in the practices, not everybody was keeping clear that if you've got a conversion factor, the top and the bottom must be in the same thing. 1 mile is 5280 feet. 5280 feet is equal to 1 mile. In this case, the feet cross off. There's units on top, units on the bottom. We need another conversion factor to get rid of miles because our desired unit is in kilometers. So if I use 1 mile equals 1.61 kilometers. Miles cross off. These two things are equal. Kilometers is our unit. Kilometers is the unit we want. So multiplying everything across the top, 300 times 1 times 1.61. 300 times 1 times 1.61 equals. So I'm going to have 483 over 483 over 1 times 5280 times 1, 5280, and the unit that we're left with is kilometers. So if I do that math, 483 divided by 5280 equals 0.09 kilometers, or 0.0914. Km, if I were to want to put that into scientific notation, move the decimal over twice. I could also say 9.14 times 10 to the negative 2, since it took 2 jumps to go back. Km. Either one of those answers would be acceptable. Alright, looking at the next one. An adult mayfly only lives 1 day. How many minutes is that? So if you're going to try to do this on your own, you could pause the video and then restart after you've made your attempt. So I'm going to start mine. 1 day is our given. 1 day over 1. And We've got a couple of time units here. A day goes into an hours, and then hours go into minutes. So I've got a day on the top, I need a day at the bottom. 1 day is equivalent to 24 hours. Day crosses off day. 1 hour is equivalent to 60 minutes. Hours cross off, at least with minutes. Answer that I was looking for. Forgot to highlight. 1 day was my given. Minutes was my desired unit. And then bottoms are all 1, so I can kind of ignore those since anything divided by 1 is itself. That leaves me with 1 times 24 times 60, or just 24 times 60 equals 1,440 minutes. 1,440 minutes, or putting in scientific notation, 1, 2, 3, 1.44 times 10 to the third minutes. Either one of those would work. Alright. Number 3. Venus gets as close as 24 million miles away from Earth. Light travels at 299,792,458 meters per second. How long would it take to get a radio a message to Venus? So if you're going to set this up yourself, do that now. Pause. I'll go through mine. So problem number 3, my given, I've got 2. This many miles and this many meters per second. I have to be careful that how long would it take? My unit then is going to be some sort of time. So if I'm going to have a unit of time, that means I need to take this speed and actually have that upside down. So there's a couple ways I could do that. I could start with the speed, or I could start with the miles and know that I'm just going to have to flip the speed upside down, put the seconds on the top and the meters at the bottom. I already know that this is going to have to be flipped anyway, so I'm just going to wait that till later. So if I start out with 24, 1, 2, 3, 4, 5, 6 miles over 1, light travels at this speed, but let's that speed is in meters. I've got unit of miles, so I need to get it out of miles into meters so that those two things can agree with each other. So I'm going from English to metric, looking at my set of conversion factors. I know that my miles and kilometers is here, so if I put 1 mile at the bottom is equivalent to 1.61 km. That'll get rid of my miles, give me meters. So I'm in metric, and then 1,000 meters equals 1 kilometer. So if I put the 1 kilometer here and the 1,000 meters on the top, kilometers cross themselves out, leaves me with meters, and I got this meters, which I actually don't want. I want the second unit because that's a time. So I put that at the bottom, 299,792,458 meters under 1 second. Those meters cross off, and I'm left with a unit of time. Now, there's a lot of numbers here, so I'm actually going to do the full math. The bottom's not going to be different because 1 times 1 times 1 times this will be 29,979,2,458. The top number will be our original distance, 24, 1, 2, 3, 4, 5, 6, times the 1.61 times the 1,000 times 1, which I can ignore. 386,4 It's 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6 zeros. So, I already have the math going right here with the unit of seconds. So I'm just going to divide it by my original number, 249,792,458. And that means the answer to this would be 15.46 seconds. Because that's this number divided by this number. Once again, if I wanted to do that as scientific notation, just slide the decimal over once, 1.54, ignore the 6, times 10 to the 1, since we made one jump, second. So 15 seconds to get a message from Earth to Venus. It's pretty reasonable. Next one. NASA's Johnson Space Center is 1,194 kilometers away. I wanted to travel there in 24 hours, supposedly to, I don't know, maybe reach a launch or get an important message from space. In the next 24 hours, how fast did I have to drive in the desired unit? Miles per hour. So that means miles over hour. So if I take my given information, I don't put it over 1 necessarily, because I actually want an hour at the bottom. I've got this much distance and that much time. 1194 km under 20 over 24 hours. And then I got my hours at the bottom. I just need miles at the top, which I do have the 1.61 km per 1 mile. Just cross off, and this one is a pretty straightforward computation. I'm actually going to do this math on the calculator in 2 steps. 1194, that was my original distance, divided by the 24 hours, equals, because you can do that division, equals your friend. If you're ever in doubt, hit equal between computations. And then I need to divide that by 1.61. So we could mosey from here to Johnson Space Center at 30.9 miles per hour and still get there in 24 hours. Seems reasonable. That's just HR. Or I can use that scientific notation, 3.09 times 10 to the first miles per hour. I have some students that want to do it MPH, which is understandable. To give that the correct unit, just make sure that it doesn't confuse you in setting up the math and the big fraction. Last one, big numbers. And this is a real number as well. So this planet, which the Kepler probe has found 16 light years away, and it looks like it is possibly inhabitable with liquid water on it. We want to turn that into a kilometers. So let's set it up. With our first given, 16 LY for light years. The conversion factor, big number here. So if this is hundreds, thousands, millions, billions, so this is 5,879,000,000,000, give or take a few 100,000, 100 million miles per 1 light year. And then we want to get out of miles into kilometers. So we know that 1 mile is equal to 1.61 kilometers. Light years cross off light years, miles cross off miles. You're left with kilometers, which is the desired unit. Probably should have put this at a speed. Maybe I'll do that as the last one. So So I take 16 light years times the